Hi, and welcome back to Lecture 18 of the course Agricultural and Biosystems Structures Engineering. This will be on the topic on the analytical techniques used in the laboratory and also in the field to assess or to determine the properties of materials of construction. Previously, the discussion was on the defects, okay, and the techniques to counter these defects, particularly for concrete and metals. There was a zoom-in discussion, okay, a focus on discussion on the metals and the alloys or the other non-ferrous metals used to combine with these non-metals, with this metal, with the steel, okay, with iron, produce steel and other alloys, which are of different characteristics to the iron when it's in its pure state. Here, okay, we discuss the different laboratory tests identified here. Okay, we have the generic tests of surface and structural analysis, microscopy, chromatography, mass spectrometry, thermal analysis, physical properties, NMR analysis, and NMR and FTIR analysis. There are also material-specific tests. We have here 8 as well: phenolphthalein test, chloride content test, linear polarization, which are the 3 of which are for concrete. 4, you have your continuity test, which is for the reinforcing bar or the steel used in the as reinforcement to the concrete to provide it tensile strength. You have your straight current test, resistivity test, delamination test, and petrographic analysis, which are all for reinforced concrete. Now let's go to each of these tests, proceeding first with the surface and structural analysis or for the generic laboratory tests. Okay, so here we look into the microstructural characterization of materials, and this is because the microstructure is influenced by the chemical composition and the processing or production process that was used to make the material. So we correlate that microstructure with this with the other properties. Okay. Next is microscopy analysis, and this is important as well to determine the microstructure or nanostructure of materials using or with the aid of a microscope. Okay. Chromatography. There are a lot of ways to do this. You have iron chromatography, the most common of which is also gas chromatography or liquid chromatography. There are other more advanced or modern chromatography techniques, but the basic idea of chromatography is to identify the molecular components, okay, via molecular separations analytical techniques. Okay. And then you have your mass spectrometry analysis, and this offers precise, okay, quantitative and elemental analysis, and could trace very small amounts of materials with proper instrumentation. And then you have your thermal analysis. Okay. This can be done for various materials such as polymers, plastics, composites, even okay, laminates, okay, other organics such as biosystems materials, right? And the tests determine the type of material, if it's an endotherm, exotherm, the phase transitions that can occur, and also the changes such as the strain, different changes due to heating. Okay. So that is probably for that is used for high heat applications. Okay. You have also your physical properties testing, and well, this is more of measurements. Okay. Dimensional measurements. Nuclear magnetic resonance analysis or NMR analysis. Okay. Nuclear magnetic resonance. This is a type of spectroscopy, and it gives data on the quality and arrangement of atoms in the system that is being studied it could be liquid or solid. And for the case of concrete, that is very much possible. Last but not the least is the FTIR, or Fourier transform infrared spectroscopy. This identifies the chemical bonds in a molecule by producing an infrared absorption spectrum. Okay. You know the spectrum, right? So you have a spectrum. The spectra produced is a profile, and this is a similar to the fingerprint. This is very distinctive of that material, okay? And then could be used to identify similar materials out there. Okay, so that's done. With that done, we have now the material specific tests. We proceed first to the phenolphthalein test, which is to determine the depth of carbonization of the concrete. Next, carbonation. And then you have the chloride content test, which is to identify chloride corrosion. It is done for the metal of the concrete. In places where there is very high chlorine content in seawater and also in plants. Okay, in what I mean is production plants where there is the use of chlorine to sanitize equipment and other materials. The chlorine, okay, would because it is unstable, it would turn into its gaseous phase and react or corrode the metal in the roofing, okay, in the beams or the ceiling, okay, the beams or the trusses of the structure or the building, okay. Next is linear polarization, which is to determine the corrosion rate, and this is in conjunction to the second, okay. You have your continuity test, and this is to test the connectedness of the rebars inside a reinforced concrete structure. You have your stray current test, and this is just to determine stray current. A stray current is an unexpected current in a certain location, okay, due to an open circuit source, okay. So you have electricity straying towards a certain location, and this is very dangerous in certain buildings and structures, okay, because people may unknowingly be electrocuted. All right, so you have next is resistivity test, and this is to determine the concrete resistivity and corrosion of the concrete. Okay. Next is the lamination test, and the material is actually very much in principle a laminated. Okay, the concrete is laminated in principle, and when you see the delamination test, it actually sees if the lamination is occurring. Okay, so the material is going to break down in sheets. Okay, and then you have your petrographic analysis. Okay, this is a review of the concrete matrix using microscopy. So this is in relation to number 2, okay, microscopy. So you have your microscopy related to petrographic analysis, and this is based on the American Society of Testing and Materials C856, okay, ASTM 856, that is a standard, and determines the concrete constituents and the quality and the cost of whatever defects there are in the concrete. So with these analytical techniques there are available in the market today, there's a lot or there are no more reasons for the engineer to be able to perform the tasks of creating quality and well, with good structural integrity buildings and structures. This is to be further discussed, okay, within the next lecture, where materials are considered in their service conditions. I will be seeing you by then, and thank you for listening. I'll be saying goodbye for the meantime.